The next method, Vogel's approximation. Vogel's approximation method. Another name for this is, I already gave you, penalty cost method. Penalty cost method. Again, let us write the same example. I wrote a new word called penalty. After giving some gap, here I gave some gap and then I wrote penalty. Similarly, I gave some gap here and then I wrote what is called as penalty. It's called as penalty. Penalty means difference between least cost and next least cost. Difference between least cost and next least cost. What is that? I will explain this with this example only. Okay, so I wrote penalty in both rows, for the rows also, for the columns also. That means we are supposed to calculate penalty for each row and for each column. So I already wrote what do you mean by a penalty. I wrote it as difference between least cost and the next least cost, right? So let us come to the first row. In the first row, which is the least cost? 4 is the least cost. Which is the next least cost? 6 is the next least cost, right? What is the difference between these two? 6 and 4. It is 2. Right? 2 here. The cost, which is 4, 9, 8. Which is the least cost? 4 is the least cost. Next least is 8. What is the difference between 4 and 8? It is 4. I mean, I should rather write, instead of writing difference, I will write absolute difference. Absolute difference means don't consider negative and all. Means it is not 4 minus 8, negative 4, nothing like that. You are taking the absolute difference. Means modulus of 4 and 8. Means modulus of 4 minus 8. You are taking that absolute difference. Fine. Okay. Next. Third row. Least cost is 1. Next least is 2. What is the difference? It is 1. Now we had done penalties for the rows, right? Now come to the penalties for columns. First column, what is the least? 1 is the least. Next least is 4, isn't it? Least is 1, next least is 4. Then what is the difference? Coming to the second column, what is the least? 2 is the least. Next least is
8.
8. So the difference between 2 and 8 is 6.
6.
Third column, least is 4, next least is 6. So the difference between them is 2.
2.
So this is called penalties. You have calculated penalties for both rows as well as columns. So let me just briefly write whatever I told now. Calculate penalties for each row and column. Then further, identify the largest penalty. Identify the largest penalty among them. Among them means among them when I say inclusive of rows and columns together. Together, which is the largest penalty. It may occur in any row or column. That largest penalty may occur in any row or any column, right? Choose that row choose that row or column for allocation and choose that cell, which has the least cost for allocation. So what I wrote, calculate penalties for each row and column. That we have done it. For each row we calculated penalties, and for each column also we calculated the penalties, right? Next, identify the largest penalty among them. Means you wrote some numbers in rows also as penalties, some numbers in columns also as penalties. Fine. Now, identify which one is the largest. That means that largest may occur either in some row or it may occur in some column. Whatever it is, identify which one it is, whether it is in a particular row or in a particular column, identify that. Then, in that row or column, whichever cell is having the least cost, there you have to start your allocation. That is what is written here, right? Now, whatever is said here, let us go and do that. I am scrolling up once again. Now, among all these penalties, which are the penalties? 2, 4, 1, 3, 6, 2. Among all these penalties, the largest penalty is what?
6.
6. That is occurring in second column, right? That is occurring in second column. In second column, which is the least cost cell?
2.
2. This particular cell is the least cost cell, means it is occurring in third row, second column. So there we have to start our first allocation. So when you come to this particular cell, what do? You compare again what is written in the supply, what is written in the demand, or what is written in the row, what is written in the column. So it is written 5 here, 10 here. Which one you choose? You choose whichever is the least. So 5 or 10, you have chosen 5. So enter 5 here. Since I wrote this 5 here, I need to cross this. I need to cross this, cut this, right? Now, 5 is already done. That means I should reduce this 10. Since 5 is already done, I should reduce this 10 to what? 10 should be reduced to what?
5.
5.
5.
Very good. It should be reduced to 5.
5.
Right? This is the way you do allocation in this particular method. What is that method? It can be called as penalty cost method. Okay, now why they are calling penalty cost method? You had initially focused on the largest penalty. So there is a focus on penalty. And then after that, what you did? After identifying the largest penalty, wherever it is occurring, whether it is occurring in a column or it is occurring in a row, you are going to that particular column or that particular row. Here what happened? You identified the largest penalty as 6, so you went to the second column. In that column, what you did? You identified the least cost. That is why you are giving focus on both penalty as well as cost. In the previous method, which method? Least cost method, you are only focusing on least cost. Whereas in this third method, you are not only focusing on least cost, you are also focusing on penalty and also least cost in that. So that is the improvisation in the previous method. Are you clear about it? Previous method, you are focusing only on least cost. This third method, that is penalty cost method or Vogel's approximation method, in this you improvised the least cost method, means you brought in one more factor called penalty. Penalty is also called as opportunity cost. You are focusing on penalty also, and then what you are doing? You are first choosing the largest penalty, and wherever it is occurring, you are going to that particular position and looking for which is the least cost cell, identifying that cell and doing your allocation like however you are doing in NWCR and LCM. Same method you are adopting even here also. Means comparing the row quantity, comparing the column quantity, whichever is the least, you are choosing that and entering there. And then whatever cancellations needs to be done, reductions needs to be the above. Repeat the above for each allocation. For each allocation until until all cells, until all cells are filled or filled in. Means what? Again, we have to start with identifying penalties, right? First row, is there any change? No change, because the least still is 4 only. The highest is, next least is still 6 only. No change in the penalty. Are you getting it? First row, there is no change. 4 and 6, penalty remains as 2 only, right? Second row, again, no change because nothing is filled in this particular row. So least cost is 4 only. Next least is 8 only. So penalty doesn't change. It remains as 4, right? Now, coming to the first column. Now there is a change because this is already done. You should not consider now. Are you getting? In the first column, the third cell is already over. Don't consider that. So that means only these are the 2 cells which are remaining. 4 is the least. Next least is 6. So what is the penalty then? 2, right? Now coming to the second column. 8 is the least now. 9 is the next least. The difference between them is 1. So this also will change to 1. Last column. 4 is the least now. Next least is 8. Difference between them is 4. So this also will change to. So what are the new penalties now? The new penalties are 2, 4, 2, 1, 4. Isn't it? First one is 2, this one. Then you have 4. Then you have this 2. Then you have this 1. Then you have this 4. Now, which is the largest penalty?
4.
4 is the largest penalty, right? But again, you may notice 4 is occurring in 2 places. It is occurring here also. It is occurring here also. Theoretically, you can choose any of them. You can choose this also. You can choose this also. No harm at all, right? Suppose sometimes it may so happen, you may choose this 4. I may choose this 4. Your solution, my solution may change. You may get a different solution. I may get a different solution. No problem at all. But when we proceed further using the same, your solution you will be using, my solution I will be using. You will try to find out what is the optimal solution. I will try to find out what is the optimal solution. When we come to the optimal solution, both of us, you and me, will get the same solution. That is the surprising thing which will happen. Even though basic feasible solution of yours may be different from basic feasible solution of mine, but still, when you come to the optimal solution, both should get or will get the same optimal solution. That is the beauty of this, right? But anyway, as I spoke about some logic previously, same logic we will try to apply here also. What logic? First, let us assume I am choosing this 4. Means the 4 which is sitting in the second row. Suppose if I choose this 4 as my penalty, highest penalty, then I need to allocate to this row. In this row, I will identify what is the least cost cell. Least cost cell is this cell, means second row, first column cell. So I need to do my allocation to this cell if I choose this 4. Am I right? I need to, if I choose this 4, I need to allocate to this cell. Why? Because in this row, the least cost cell is wherever this 4 is sitting. So when I come to this cell, what will be my allocation? I will compare 6 and 12.
6,
My allocation will be 6. Coming to this 4, suppose instead of choosing this 4, if I choose this 4, what will happen? Least cost is again this 4, right?
4,
If I choose this 4, how much will be the allocation? Can you tell me quickly?
14.
Very good. That means which is better to choose? Whichever gives me maximum allocation is better to choose. That means I will not choose this 4. I will choose this 4 to have a better logic. Why? This 4 is allowing me to allocate only 6 units, whereas this 4 is allowing me to allocate 14 units. So let me choose this 4. Are you clear about it?
Yes, sir.
Good.
Yes, sir.
So I will choose this 4 and I will go to this particular cell. In this particular cell, I will compare 14 and 15. Among this 4 and this 4, we decided that we will choose this 4 because we are able to allocate more quantity. That means 14 units we are able to allocate to this cell. So I had chosen ultimately this penalty, that is this 4, and we will allocate to this particular least cost cell as 14. Now, this 14 is fully done, so no more allocation here, no more allocation here. Since this 14 is already done, this 15 I need to reduce it to 1. Clear?
Yes, sir.
Yes, sir.
Good. So, now, which are the cells left? Only the second row is left, right? Now, coming to the second row, recalculate penalties, because every time you have to repeat the step, isn't it? So in the second row, least cost cell is 4. Next least cost is 8. The difference is same only, no change. It is remaining as 4 only. Now, coming to the first column, how do you calculate penalty for the first column? Nothing. Nothing means 0. So there least cost is 0. Next least is 4. Are you clear? When I come to this column, only one cell is there. That cell is having 4 only. Other number, somebody is asking, where is the other number? You say nothing. Nothing means 0. So you have to subtract 4 minus 0. 4 minus 0 gives you 4. So it is like this. For example, you want to transport some material of yours to, let us say, Cochin. You want to transport some material of yours to Cochin. Only one transporter is available. You don't have any other transporter who is ready to take your material to Cochin. Then whatever he is going to charge you, are you going to accept it or not? No option, no? So that itself is a penalty. Means only one choice is there, that is 4. 4 minus nothing. So the penalty becomes 4 only. Are you clear what I'm saying?
Yes, sir.
Okay. Now similarly coming to the second column. Only 9 is there. Nothing else is there. That means 9 minus 0. 9 minus nothing. 9 minus nothing means 9 minus 0. 9 minus 0 means this penalty becomes 9. Then the last column, 8 minus 0, 8 minus nothing, 8 minus 0, it becomes 8. Is it clear?
Yes, sir.
Good.
Yes, sir.
Now what is the largest penalty?
9.
Yes, sir.
Largest penalty is
9.
9, right?
9.
How? Because 2 here, 4 here, 4 here, 9 here, 8 here. Of course, largest penalty is 9, which is occurring in the second column. Second column, which cell we have to allocate? Only one cell is blank. We have to allocate there only, which is that this cell, centermost cell. When you come to the centermost cell, which are the quantities you are comparing? 5 and 12. Which are the quantities? 5 and 12. So your allocation will be the least quantity, which is 5. Which is 5. So you allocate at 5, which means this 5 is fully done. This column itself is over. Cut this penalty also, right? 5 is already done. So this 12 has to be reduced to 12 minus 5. It will become 7.
7.
One more thing, the first row, if you look into, the completely it is done, isn't it? So cut this also. I didn't cut that time. Right? Now, second row, 2 cells are blank. So what is the penalty? 4 is the least. Next least is 8. No change in the penalty. It is remaining still 4 only. Right? Coming to the first column, 4 minus nothing means 4 minus 0. It is 4 only. Second column, already over. I already cut, nothing to be done. Last column, only 8 is there, means 8 minus 0, it is 8 only. So what are the penalties left now? One is 4, this 4, then this is the one more 4, then this 8. Which is the largest? 8 is the largest, which is occurring in the third column. In third column, which cell to allocate? Only one cell is left. You have to allocate it there only. 1 or 7. 1 or 7. You will allocate the least quantity, which is 1. If I allocate 1, I will have to close this, close this. 1 is already allocated, so the 7 has to be reduced to 7 minus 1. It becomes 6. Clear?
Yes, sir.
Very good. Now, only one cell is
Sir,
left.
1 minute.
You have come to the last
Why
cell.
we wrote 1, sir?
Where 1 or 7, no? You are comparing those two quantities. You are allocating whichever quantity is the least. So 1, 7, which is least? 1 is least, so you allocated 1. When you come to the last cell, you compare the quantities. Quantities should be the same. Yes, it is the same, 6 and 6. Penalties also will be the same, 4 and 4. So it is matching. So allocate 6 there. Close this 6, close this 6, close this penalty, close this penalty. That's all, right? Now check whether it is a BFS. M plus N minus 1. We know M is 3, N is 3 minus 1. So it is 5 allocations. Do we have 5 allocations? First one, second one, third, fourth, fifth. So this is also a basic feasible solution. This is also a basic feasible solution, right? So here I will calculate the total cost, TC, total cost for BFS through what? Penalty cost method or Vogel's approximation method is equal to, let me calculate that, 4 into 14. 4 into 14 plus 4 into 6 plus 9 into 5 plus 8 into 1 plus 2 into 5. How much?
143.
Very good. What is that we noticed? We may note that in general, not always, in general, right? In general, Vogel's approximation method or penalty cost method will give a better solution, than northwest corner rule or least cost method. Of course, first method, what we got, the cost, I think 228, right? 228. Northwest corner rule, we got the total cost. Then least cost method, we got the cost as 163. And when you come to this penalty cost or Vogel's approximation method, you got the cost as 143. It is further lowered or further reduced. Why? Simple reason. Here we focus on both the penalty incurred by us and also the least cost. We are focusing on two factors, whereas in least cost method, we focus on only one factor, which is the least cost. And in northwest corner rule, we don't focus on anything. We only focus on direction. Northwest always means top left corner always. That is the simple reason why this is giving us a better solution than the other two, right?